This video is part of an online course of Calculus 1, and I'm going to talk about motion in a straight line. Okay, let t to be the parameter for time, and we use seconds to measure it. And let s of t be a function of positions of an object at the time t. So let me write this. So s of t would be the position at time t. And we measure it in meters, for example, starting at the origin at 0. Okay, so assume that we have a straight line. This is 0, and we are moving along this straight line, and at the time t, since we are here, that would be s of t at a time t. The question is this: what is my velocity at an exact time at the moment? So what is my velocity at an exact time, an exact moment in time? Okay, to answer this question, first we find the average velocity. So I'm gonna say the average velocity, okay, between two times, between the time A and the time B. And let's assume that, for example, A is less than B. Okay, for example, after 3 seconds I'm somewhere here, and after 10 seconds I'm somewhere here. What is my average velocity? To find the average velocity, I need to find a fraction, and on the numerator I have the overall displacement between the times A and B over change in time between A and B. So basically, to find the average velocity, I need to find the overall displacement over change in time. Okay, so I can say that I need to find a fraction. On top, it would be s of b, my position at the time b, minus my position at the time a. Okay, that gives me the overall displacement over b minus a. Okay, and pay attention that a and b are basically two distinct moments in time. So we have two distinct moment in time. Okay, so look at the graph. What's gonna happen in the graph? I have a graph of time, and then this is y-axis, and then just assume that, for example, this is the function s of t, y equals to s of t, my position. Okay, at the time a, I'm somewhere here, so this point in here has coordinates a and s of a. Okay, the time and the position at the time, and then assume that, for example, this is b, and this point in here is b and s of b with these coordinates, the time and the position at the time b. Okay, then we have a line that is passing through these 2 points. Okay, just assume that this is this line. Okay, the line that is passing through these 2 points is called the secant line, So this line in here is called secant line, and the secant line has the slope, and you see that the slope of this line is basically change in y coordinates of these 2 points over the change in x coordinate of these 2 points. So change in y would be s of b minus s of a, basically change in the y coordinates of the point, and change in the x coordinates of these 2 points would be b minus a, right? And as you see, the slope of the secant line in here would be actually the average velocity. This is the average velocity. So that's nice. To find the average velocity, all you need to do is to find the slope of the secant line if you have the graph of this. So let me write this. So look at the graph. We have this situation. Let's go over one example to see how does that work. So example, let s of t be t squared. Question is that what is the average velocity between t equals to 1 and t equals to 2. So this is our A, this is our B. Okay, let me graph it. We have t, we have y, and we have this parabola. Actually, the parabola passes through the origin, so I need to move it just a little bit. So the parabola is y equals to t squared, and okay, so at a time 1, I'm at the point 1, so this point that I get in here is the point 1, 1, and then at the time 2, when I plug in 2 into here, I got 4. So this point in here would be the point 2 and 4, and I have a secant line that is passing through these 2 points. Okay, let me just move this one a little bit. Oops, this one stayed. That was y equals to that. So I'm gonna say that the slope of the secant line is the average velocity that I wanted, which would be the function at the second point, which is 2 squared, minus the function at 1, which is s of a, 1 squared, over 2 minus 1. So this is 4 minus 1 over 2 minus 1, so this is 3. That's the average velocity. Now another question that you can ask is that what if a and b are equal to each other? So the next question is this: what's gonna happen if a is equal to b? Then the slope would be undefined. It's just because we get the 0 on the denominator, right? The slope is undefined because denominator is equal to 0. Now, what is velocity at a single moment? Single moment. What does velocity in single moment mean? Velocity in single moment mean? Okay, I'm gonna answer this question in the next video, which we're gonna talk about the instantaneous velocity.